in this video I'm going to take some previous year questions from the chapter fluid statics. Okay, let's take on this first question. For a completely submerged body with center of gravity G and center of buoyancy B, the condition of stability will be a direct question from your theoretical part, that for a completely submerged body G should be below B. Okay, so answer is A. However, the second case which we study is that for a floating body, what is the condition for stability? That the meta center M should be above G. Okay, for a floating body. So next question. The difference in pressure across an air bubble of diameter 0.001 meter immersed in water, surface tension is given as 0.072 Newton per meter. Okay, so excess pressure for a liquid drop or air bubble is equal to, let me write, excess pressure for a liquid drop liquid drop or air bubble is equal to 4 sigma by D. I've studied this. I'm not going to derive this formula. This is equal to 4 sigma by D. So sigma is surface tension and D is diameter, which is given as 0.001 meter. So put the values, you will get the excess pressure as 288 Newton per meter square. Take care of the units that you have to fill the answer in Newton per meter square, and you have got the answer in Newton per meter square. So the answer will be 288. Okay, note one thing, that for a soap bubble with two surfaces, the excess pressure is 8 sigma by D. Okay, this is an important point. This also you have derived all in your class or whatever, from which book you have studied, you must have derived this also. Okay. Next question. A spherical balloon with a diameter 10 meter, diameter is 10 meter, shown in the figure below, is used for advertisements. The balloon is filled with helium, okay, at ambient conditions are given. Assuming no disturbances due to wind, the maximum allowable weight of balloon material and rope required to avoid the fall of the balloon. Okay, when you analyze this question, what you see is that the maximum allowable weight of balloon material and the rope required to avoid the fall of the balloon is equal to the net buoyancy force. Okay, so what we will do first, we will find out mass of balloon. Okay, and how can we find out mass of balloon? Will be volume of balloon into density of helium, correct? Yes. What will be the volume of balloon? Volume of balloon will be 4 by 3 pi r cube. Okay, this is diameter, be careful, do not put 10 meter as radius, be careful, r will be 5 meter then. Okay, density of helium, how will you calculate the density of helium? Can we apply this formula, this equation for ideal gas? Pm is equal to rho RT, rho helium. Okay, so rho helium is equal to, okay, let's take this M below this R by M will be R helium. Okay, universal gas constant divided by its molecular weight, the gas molecular weight gives the characteristic gas constant, which in this case is helium. Okay, so rho helium will be P characteristic gas constant of helium into temperature. Okay, we know the values. Yes, we know the values. This is given, this is also given, this is also given. Put the values. The mass of balloon will be 87.359 kg. Okay, now next we have to find out mass of air. Okay, as I have already said that the maximum allowable weight of balloon and rope required to avoid the fall of the balloon will be equal to the net buoyancy force. Okay, so net buoyancy force will actually be equal to weight of air displaced minus weight of balloon. Okay, so if we find mass of balloon, multiply it with g, we will get weight of balloon, and if we find mass of air, multiply it with g, we will get weight of air displaced. Okay, and the net buoyancy force is equal to weight of displaced air minus weight of the balloon. Okay, so what is the mass of air? Mass of air will be volume of air displaced into density of air. Similarly, volume of air will be 4 by 3 pi r cube. R, you know, it is given as 5 meter for the sphere. How will you calculate the density of air? Again, applying this formula for the ideal gas, and this you will get as P by R air into T. Okay, put the values. This will be around 628 kgs. Okay, now buoyancy, net buoyant force will be weight of displaced air, that is 628 into 9.81 minus weight of the balloon, that is 87.359 into g, 9.81. so this will be the net buoyant force, and this net buoyant force will be equal to the maximum allowable weight of balloon material and rope required. Okay, next question. Prandtl tube, pitot static tube with C is equal to 1 is used to measure the velocity of water. The differential manometer reading is 10 mm of liquid column with a relative density of 10. Okay, note down this data. Assuming G is equal to 9.8 meter per second square, the velocity of water is, okay, let's construct a rough diagram first. It's very difficult to construct the diagram on this. I hope you get the idea. Okay, this is a rough diagram. So water is flowing here. Okay, this is the manometer liquid, and this difference, let it be x, which is given as 10 mm. So x will be 10 mm, that is 0.01 meter. Okay, so this reading is given as 0.01 meter, and we have to find the velocity of water. What is velocity of water? Cp root 2gh. How can we write this? You know this, by applying the Bernoulli's equation, you will get on to this result. Okay, so V is equal to Cp root 2gh. However, h here is x rho manometric, I mean density of manometric fluid upon density of water minus 1. Okay, and the relative density is given as 10, so this becomes 10. This is given as 0.01 meter, so putting the values, h will be 0.09. okay, put the h here, velocity will be 1.328 meter per second. Okay, so this formula you can get by applying the Bernoulli's equation between this point and this point. Okay, this 1 and 2. Okay, next question. For a floating body, buoyant force acts at the, okay, this is the definition of center of buoyancy. Listen it carefully. that the point of application of buoyancy force is known as the center of buoyancy, and it will act at the centroid of the volume of the fluid displaced. So what will be the answer? Answer will be D. Direct question based on the theoretical part. An inverted U-tube manometer is used to measure the pressure difference between two pipes A and B as shown in the figure. Okay, pipe A is carrying oil, specific gravity is given, pipe B is carrying water. The densities of air and water are given respectively. The pressure difference between pipes A and B. Okay, how do you approach these type of questions? You need PA minus PB. Okay, take care that you have to take acceleration due to gravity as 10 meter per second square. Okay, so where was I? Yeah, you have to find PA minus PB. Okay, so in these type of questions, what you do is you start from A and you have to reach B. Okay, so let's begin. Okay, at this point let the pressure be A. Okay, now at this horizontal line, at this point and this point, the pressure will be same. Why? Because there is no difference of height. Okay, so if there is no difference of height, the pressure won't change, and you are in the same fluid. Condition is that you are in the same fluid. Okay, so here is oil, here is also oil, H is same, so pressure here will be same. Okay, wait, now you move upwards. As you move upwards, the pressure will decrease by a value rho gh. Okay, so minus rho of oil g, and this h is 200 mm, so I am directly writing it as 0.02 meter, sorry 0.2 meter. Okay, now can you jump from this point to this point? No, you cannot jump from this point to this point because this is air and this is water. Okay, so you have to travel 80 mm more. Okay, and the pressure will again decrease because you are traveling upwards. Okay, so as you go upwards, pressure decreases, that is minus rho of air g. What is the distance? Distance is given as 80 mm, that is 0.08 meter. Okay, now from this point I can jump here because the medium is same. Okay, so at this point and this point the pressure will be same. Great, now we start moving down and reach this point. Okay, what is the distance that I have moved down? It is 380 mm, that is 0.38 meters. Okay, so the pressure will increase by rho gh, rho of water g, and h will be 0.38 meters. Okay, now you have reached this point. Okay, draw a horizontal line at this point and at this point. The pressure will be same because the medium is water and there is no height difference, so that is equal to PB. We reach point B. Take this B here, take all this value on the right hand side, PA minus BB. Solve this, all the values have been given. PA minus PB will be 2157.28 Pascal. Before filling the value here, check in what units you have to fill the answer. You have to give the answer. You have to give the answer in kilopascal. So that will be 2.157 kilopascal. Okay. Next question. Assuming constant temperature condition and air to be an ideal gas, keywords constant temperature condition and air to be an ideal gas, the variation in atmospheric pressure with height calculated from fluid statics is. Okay, according to fluid statics, can I write dp by dz is equal to minus rho g? This is height, this z represents height. Okay, so dp by dz is equal to minus rho g. Okay, so from ideal gas law, P is equal to rho RT. Right, so rho is equal to P by RT. Put this value here. Okay, now what you get, dP by dz will be minus T by RT G. Okay, now that implies, now it is only integration part, so minus G by RT dz, integrate it, take the minus sign outside, integrate it from 0 to P, 0 to H, solve this, and you will get the relation as P is equal to e raised to the power minus GH by RT. So what is the variation? The variation is exponential. Okay, so the variation in atmospheric pressure with height is exponential. Next question. Okay, the large vessel shown in the figure contains oil and water. A body is submerged at the interface of oil and water such that 45% of its volume is in oil, while the rest, that is 55% is in water. The density of the body is, specific gravity is given, density of water is given, all the data is given. So can I say that the net buoyancy force will be equal to the buoyant force by oil and the buoyant force by water? Okay, and also the net buoyancy force will be equal to the weight of the body. Okay, let's write this first. Net buoyant force is equal to weight of the body, okay, and net buoyant force is equal to the buoyant force by oil and the buoyant force by water, which will be in the upward direction. Okay, buoyant force acts in the upward direction and weight of the body will be in downward direction. Okay, so the net buoyant force by oil and water becomes equal to the weight of the body. Okay, this will be equal to weight of oil displaced plus weight of water displaced, and that will be equal to mg. Okay, let m be the mass of the body. Okay, so what will be the weight of oil displaced? That will be equal to rho vg, where rho will be of oil, v, what percent of volume is in oil? 45%, so 0.45 v rho vg. Okay, plus weight of water displaced, what percentage of the volume is in water? That is 0.55, so rho water into 0.55 v into g. mg, how can I write m? M can be written as rho of body into volume of body, which is v. I've assumed the volume of body as v. Let the volume of body is v. Okay, this is understood already. So rho body into v into g. G gets cancelled out, v gets cancelled out. Oil, density of oil is given, density of specific gravity of oil is given, so this will be 700. Density of water is 1000. Solve this, you get the density of the body as, I guess it will be equal to 865 kilogram per meter cube. Okay, pretty simple question, that net buoyant force is equal to weight of the body. That's it, nothing more conceptual. Okay, so consider a frictionless, massless and leak-proof plug blocking a rectangular hole of dimensions 2r into L at the bottom of an open tank as shown in the figure. Great. The head of the plug has the shape of semi-cylinder of radius r. Okay, underline this, semi-cylinder of radius r. The tank is filled with a liquid of density rho up to the tip of the plug. So this is r. Great, this is given as r. This is the semi-cylinder. This cylinder actually extends backwards. Okay, imagine this. You have been given the view also. So this length is L. Okay, L. The tank is filled with a liquid of density rho. Okay, the gravitational acceleration is G. Neglect the effect of atmospheric pressure. The force F required to hold the plug in its position is. Okay, let's zoom this first. Let's draw a rough figure. Okay, so this extends backwards. Okay, imaginary, I mean this length is L, because this is semi-cylinder of radius R. This is R, this is R. Okay, let me complete this. This shaded portion is what? This is a fluid of density rho, and in this portion also same case, fluid of density rho. Okay, so can you guys tell me what will be the total volume of this semi-cylinder? Okay, काटना पड़ेगा, भाग। क्या, थोड़ा तो देख लेता क्या बोल रहा है। शिट।